Hello, Justin, Cory. Thanks for joining us. We're here looking at the PrintPods. I was at IDS, ton of energy in the Asiga booth, looking at this very innovative container that has resin in it. I can't help myself but to think of a Keurig cup, and I know it's a little more sophisticated than that. So, Justin, I would love to hear from you. Where did the idea for PrintPods generate? What are the innovation behind it? And let's just jump in describing, what this is, the innovation, and what these are all about.
Hi, Rob. Yeah, great to be with you today. So the print pods came out of an idea of trying to serve the needs of a dental clinician who has very different requirements to a dental laboratory technician. So in a dental clinic, sorry, in a laboratory, you would say that technicians tried to make a large number of restorations efficiently and quickly, whereas a clinician is really obsessed or driven to provide for a single patient who's got their mouth open in front of them very efficiently. And we realized that in order to do that, we had to minimize the handling and mess involved with creating a 3D printed restoration. So we wanted to put all of the components involved. That means delivering the material, the platform that the object is built on, to the printer in a small dosed amount. So it only contains, like, it's less than a shot. So it's only around 10 to 20 mils of material. And yeah, it allows a clinician to print something, a restoration in around 10 minutes and do it without getting their hands messy.
So 10 minutes for a crown, and then if there's leftover resin, they can screw the cap back on and store it for a second crown. How many crowns could you get out of an average print pod, maybe?
So yeah, the idea is you can get around 5 prints out of a print pod. So it's reusable. And again, like a clinician doesn't necessarily want to be maintaining a large stock of different colors or different restoration materials, and they might only use a small amount. So by having a small amount in a container allows, a diverse range of colors to be kept in stock, which you might only use a couple of times.
I mean, I just love the idea of no mess, right? You're not pouring anything out of a bottle or trying to pour it back into a bottle. It's just the bottle is the build tray, right? I mean, that's really the innovation, that the pod is the build tray. Unscrew it, put the attachment on there, print your job. And then does the printer measure how much volumetric consumption of resin was pulled out, so it kind of knows how much is left? So it's kind of keeping track of the residual resin in that print pod.
Yeah, that's correct. And so the print pod, after each print cycle with that print pod, the printer is able to identify the exact print pod and detect how much consumption was used to that print pod itself.
So Justin, who is responsible for coming up with this innovation? Was it like you're riding a motorcycle in the desert and you came up with this idea, or like a whiteboard session with the R&D team? What was the genesis of the print pod and its idea at Asiga?
Well, look, I think necessity is the mother of invention. You know, one of the most important growth areas at the moment is the chairside digital dentistry applications. And so, I was thinking about how we could satisfy the needs of a clinician. And yeah, I was just brainstorming ideas, and it seemed like the simplest solution, and got the mechanical team involved, and this is what we came up with. And from start to finish, it was all conceived of and prototyped in about a month. So it's had we've been now looking since IDS, where we had a great reception to the product. And we're rolling it out to all of the material manufacturers around the world. And in Q3 of this year, we expect it to be available to users.
That is amazing. So you had the idea and you iterated a prototype, you said, in about a month?
Correct.
That must mean you have a pretty awesome R&D team. You guys are investing heavily into R&D. Obviously, we've seen a number of new products come out from Asiga. So from ideation to IDS, How many months elapsed? How quick of a dev cycle was it to go from ideation to showing it at IDS?
The the ideation to IDS, it was approximately 5 weeks. And so
What?
yeah, 5 weeks. It was pretty amazing. And so it was something that
Hold on.
we,
I'm having a hard time wrapping my mind out of that, Cory. Like the idea in the boardroom, drawing it on the whiteboard to IDS was 5 weeks.
yeah. And so we're able to, we had a, like we had some meetings about like how we vision the clinical market and how we wanted it to, what we wanted to do with the clinical market and approach it with 3D printing. And so everybody like gave their best shot of what they felt a clinical solution would look like. And so I think that's really what generated the ideas to get to that point. But once it finally got on the whiteboard to IDS, it was about 5 weeks.
Wow, that's
And
amazing.
that's really a testament for the team that we have. We're able to be extremely agile and pivot really at any moment. And the engineering team that Justin has hired and has hand selected, they're phenomenal. And we're extremely proud to say that this is all in-house solution. So nothing was, outsourced. And it's pretty amazing to be able to say that us as a team, we were able to pull that together so quickly and so efficiently and so beautifully at the same time.
So Justin, I had asked Cory, how much time elapsed from the ideation to IDS, and you're saying about 5 weeks.
Yeah, it was around 5 weeks, really. It was more like about 6 weeks, but all of the work happened in about 4 weeks, and then there was the prototyping and making what we ended up taking to IDS. And yeah, it's really fast, but I think it's really exciting working in a fast moving environment where you can come up with ideas and bring them into market in a really short amount of time. And I think, necessity is the mother of invention. So working under some time constraint actually brings out the best in engineers typically. So, we're really happy with how things have gone.
Well, that is truly amazing. And Asiga being an open system, we can expect to see a number of resin providers. And, I see on your website, you've got Dentax and PacDent, Keyprint, Vita, Bagos, Ramco, Pro3 Dur. So awesome to see such an amazing innovation, but then also quickly a pretty nice variety of resins that can join into this innovation. Maybe if you're allowed to share just how many different resin partners have reached out to you to put their resin in the print pods, what should we expect to see in the coming months around just the variety of printable resins to choose from for all the different types of indications that a doctor might be interested in?
So one of the advantages of the print pod is that it's essentially using a miniaturized version of our existing print process. So bringing new materials to market or different concepts is often limited by the regulatory side, the restrictions in qualifying or having a new process verified under the controls of the regulatory bodies. So because we can draw on the existing process and all the materials that are validated with our print process, essentially all the materials that are currently usable on our platform, of which you've named several, are all compatible. So it's going to roll out really quickly. And I've lost count of the number, but it's, I think we're up to maybe 15 or so partners.
I mean, that's pretty amazing. So the one of the unlocks to this innovation is the regulatory compliance with, you have an existing, validated printer, an existing tray that has a film on it that you're going to build from. But then the print pod kind of falls into those, validated workflows. So then you're able to get it to market in a uniquely fast roadmap. Normally this type of innovation, you have an idea on Jan 1 and you're launching it like 2 years later.
Yes, it's very typical for medical devices.
Wow, that is truly amazing. Nice to see the family of resins. And then the pod itself has the film in the bottom. I know we kind of mentioned that. You know, the Asiga tray is an item that you would buy and you would pour resin into. And then when you want to clean it up, you're either pouring the resin back in the bottle or, all that kind of stuff. But in this scenario, the pod is the container and the tray itself. And so the film that's laying down and being exposed to light is just right there at the bottom of the pod. That's a brilliant innovation right there.
Well, yeah, one of the issues that a clinician might run up against is that some of these dental restoration materials for 3D printing, they can come in half-liter or liter bottles. And I mean, in a 1 liter bottle, you've got enough material to produce maybe 1,000 restorations. And that may cost you over $1,000 because some of the materials that comprise these resins are really expensive. They genuinely are very expensive. So if you've got some obscure shade, you might have a 1 liter bottle and you only need it, 3 times a year. That's a lot of investment just to sit on the shelf. And it's bulky and inconvenient. If you can take a small shot of that, a few milliliters, and put it in a small container, again, you might only use it 3 times a year, but instead of costing $1,000, it's only cost $20. Yeah, it just provides, I think, a greater accessibility to a wider range of different materials for different applications.
That's a really good point. The smaller container allows for a variety of resins, just the economics around it, right? So if I'm printing like smile mock-ups, like no prep veneers or something of that nature, I can carry 5, 6, 7 different shades and really have a greater variety because my requirement to enter into that shade is a couple of pods and not a full 1 liter bottle. That's really cool. And so obviously some great innovation here on the hardware side. I wanted to talk about some of the innovation you guys are making on the software side as well. And I know you have some software, I think you call it Genira, that is automatically basing. So you take an iOS scan and you feed it into Genira and it's basing a model for you. Is that correct?
Yeah, correct. Yes. So the idea was 0-click model basing, done completely automatically. Essentially, you configure how you like your models, where you want the text, whether you want them hollowed, how thick the wall may be. But after that's set up, you drag and drop your 3D scan data, either single cases or in a batch, and they just come back already based. So it's one of the largest applications still of 3D printing in dentistry. And so, we wanted to offer something in this space.
So is Genira still in development? Is it publicly available? Has it been released yet? Just tell us about the product itself, and is it available for users today?
It's available for beta users. So we've got some people who are just testing it out for us. We're going to be rolling it out over the next few months to a broader audience.
Amazing. So cloud-based, I assume, log in from any computer and then drop a scan. Cory, are you able to show us this no-click model basing?
Yeah, absolutely. The automated basing software, it's all completely cloud-based, as you said. And I was kind of running through it just a little bit earlier on the screen. But essentially, you'll go and you'll create a new build or create a new job. And when you're in here, you have the ability to select a design template. And so you can come in and you can add a new template. And so we'll name this one, for example, solid models. From there, I can tell if I want my models that I'm going to be pulling into the software, the scans, intraoral scans, if I want to have articulating pillars or none. So for example, for this case, I'll choose pillars, and then I can tell it if I want it to be hollow or add text. And so because I want solid, I'm not going to put it to be hollow, but I will add text, and I can choose it to be embossed or engraved. So I'm going to go ahead and choose engraved. Simply select save. And then from there, I can browse to my folder or browse to my file location. We can choose or we can use any STL file or PLY file. I'm simply going to drag and drop the case in or the scans in, and then I'll select process. Now, the beautiful thing about the Genira software is I can upload as many cases as I want at one time. And in approximately 10 minutes, we'll have our automatically model back. So our design model back for us for download. So I do have this case already done right here. And so I can go ahead and choose or select on the case itself. It'll give me a 3D render of the designs. And so I can go ahead and rotate it around and just take a look at it. This one I did use a hollow model design, and I wanted to add drain holes, so I'll automatically add the drain holes. And this one had the engraved text, and so we have our text there. And then to simply download it and use it in my printer software, I'll click on the download design option or download designs or download cases, and I can download those STL files and start using them in my nesting software. You can utilize Genera with any 3D printer in the world. It doesn't have to be just an Asiga printer. Of course, we would love it if it was off an Asiga printer, but you can go ahead and download the Genera software and utilize it with any 3D printing technology.
Well, hold on here. That is interesting. So anybody can create an account in Genera and access what you just showed us, these no-click model designs, and then download those files and print them on any printer they want.
Yeah, absolutely.
Wow.
So you could utilize it with any printer technology. There's no limitation there, and it's pretty seamless, and it really opens up the door for end users that maybe they're new to, like let's say they're, for example, a laboratory that's new to receiving digital scans, and they still want to produce some applications in an analog method. They could go ahead and 3D print their models. Or let's say maybe they don't have enough work to justify buying a more expensive model building package, and they could utilize this to supplement that until the cost offsets, and it really makes sense to invest in that. Or let's say they're just overwhelmed and they don't want to do the 20 minutes or 10 minutes to do a model build manually and just let this do it automatically for them. Same on the doctor side or the clinical side. A clinician has the ability to utilize their intraoral scan, simply upload the STL file or intraoral data to the software, and in 10 minutes have their model created without any wasted labor or time utilizing a computer. They can go ahead and upload their scan, walk away, visit another patient, come back, and then have their model ready to print.
Wow, that's incredible. So does it do crown and bridge models with removable dies, or that's not available yet, coming later?
So it's not available yet. There'll be a feature for later. Right now, we'll just take any intraoral scan and then simply just model it itself.
But I mean, this is great for, a retainer, right? If the doctor takes a scan after he removed the wire and bracket, you could easily print a model to make a retainer. Maybe some, whitening or bleaching trays, or you want to do a suck down for, sports guards, something like that. It's really, really cool.
Or what about even think about like the dental labs that just want like a check model, and so maybe they still have their standard model with the removable die, but they just want a simple check model and they don't want to have to walk back through the generation software. They could simply flick their STL file into the software and have it automatically create an unsectioned model for them.
Wow, that's amazing. So right now Genira is just focusing on models, and then Justin is the vision to really develop and expand this into other indications. Where do you want to take Genira over the coming months and years?
Well, in a way, we started work on Genira because we're trying to automate our workflow as much as possible. A bit later in our conversation, we'll talk about our funnel software, which is for nesting and automatic job preparation. But that process needs to connect with a lot of external design services. So in order for that cloud-based service to have a good API for allowing third parties to connect into it, we wanted an example that we could develop ourselves as a first case. And that was the most common application in digital dentistry, which is printing the model.
Yep.
So it was our demonstration case for our funnel. we'll see where it goes. I mean, the final frontier really in the digital dental process is the design. I think the 3D printing, the intraoral scanning, and all the post processing from there is really quite advanced now. And saving the design time is really where it's at. And there's a lot of exciting new software services from major and also some startup companies.
Yeah.
So, being an open platform, Asiga, we want to be able to connect to all those. Yeah, we're really excited about the future of those design services, as you must be as well.
Yeah, I mean, I think design is still a bottleneck in digital workflow, and it's a really important part. And it's where you're controlling the, all the nuances of the fit, form, function. And, 15, 20 years ago, all of the brain power, the dental IQ, a lot of that was invested in ceramists, right? The people controlling that porcelain buildup. And I think today we're seeing, or it's maybe even already occurred, that the digital technician that knows how to work with scans and photogrammetry and complexity and can control all those variables and design an amazing output, those are the higher paid, more valuable technicians, those design experts. And we're seeing AI take over single unit crowns, inlays, onlays, night guards. And I was a part of some of that innovation, which was a lot of fun. And I think we'll see it continue to grow. Let's talk a little bit about the funnel. So you have Genira, which is your model building software, and we'll see other indications there. Can you send a case from Genira to the funnel, or you got to download it from Genira, upload it to the funnel, and maybe in the future you'll have like a cloud integration of the two?
So we actually have a cloud integration in process. And so it's not live yet, but Genera will have a cloud integration into our funnel software along with other apps. And so the vision is that an end user, if they have the Genera software and if they have an Asiga 3D printer, they can utilize Genera funnel and their Asiga 3D printer for a complete seamless workflow that's automated. And so they would simply upload their intraoral scan, have the Genera create the model, and then they'd have a one-click button that would transfer the model data to the funnel. And then the funnel would be able to accept the work and start doing the auto nesting process, which we'll show here live in a few minutes. We also have the ability to connect with other third-party design companies as well. And so we have a few that we're working with in this for these added apps, and this will continue to increase. And so you can see
I know all of them.
Yeah. I'm sure you've worked in some sort of way, in some sort of capacity, in a little bit in each one of these companies, or at least discovered them. Yeah, and so it's a great way to really open up that workflow where a clinician, for example, if they don't want to learn the design software, or if a lab, for example, is just maybe they're overwhelmed with the amount of work that they have, if they need to outsource it, or maybe they had an employee that went on vacation, right? You always hear about that. The employee went on vacation, and of course they get the most intraoral scans during that time, and they need to supplement that work in some sort of way. And so utilizing a design service will allow or take away that design need and simply create the design for the workflow, or create the design for the dental application, and then they can feed it back to our funnel software, which in our funnel software will do the automation. And so I can give you real quick, Rob, a review of it.
There's some brilliance here I want to chime in on, because I think, tell me if I'm wrong, the problem you're really solving is a doctor getting data out of his iOS scan and sending it to a lab or a design center is relatively easy. Getting it back into his Asiga, right? Now I got to log in somewhere, download a file, go over to my funnel. But what you're showing here is the design center, whether it's an AI-driven design or a human-based design, can deliver the finished design directly back into the doctor's funnel. Is that what we're seeing?
Yeah, exactly. So that's the vision, that the automated design, whether it's AI or they use a design service, once that design is done, it'll automatically feed back to the funnel software for the funnel software to start its auto nesting, auto orientation, auto supporting, and send the job over to the printer for the end user. And so a doctor could actually technically scan a patient and send that scan off to their service, and then step over to the printer in a few minutes and just start the print. And that's the ultimate, that's the ultimate goal to have, like everybody talks about having a one-click workflow or a five-click workflow. What if we can get it to no clicks? And so they just take the intraoral scan, send it, and then they move on.
I mean, this is really brilliant. You're closing the loop on the complexity component of digital workflow for a doctor,
Yeah.
right? And they want simplicity, and so then I got to imagine then to maybe a designer that's gained trust, a remote designer gained trust with the doctor. They could even like start the build job or say, "Hey doc, throw this print pod in. I'm in your funnel and I've delivered the case and we're gonna start the build for you."
It could even go to that point. Absolutely. Yeah.
Wow. So anything to highlight as far as like what funnel is, what funnel does? Is this the actual like nesting software where you're going to check your, build supports and your angulation and that kind of stuff?
Yeah. So what it will do is you can simply drag and drop any STL file you want. And so I just grabbed 27 files over from my desktop. And but this you could upload any type of design. And so I could upload at the same time like 5 dentures, 5 splints, 5 All-in-X implant restorative cases, 4 crowns, and I can't remember if I said splints or not. Say splints, and then maybe 2 surgical guides and 27 models. I could upload it all at the same time, and as soon as I upload it in, the funnel will start categorizing the part type. And so it pulls in the parts, it analyzes the part, and it will automatically identify what the part is. And so it can find if it's a splint, it can find if it's a model, it can find if it's an All-in-X case, All-in-X denture, and it will
Hold on a second. It's recognizing the shape of the object and assigning a value automatically?
Yes. So we have
Whose idea was that? That's amazing.
I think the Justin is brilliant, and we have amazing engineers, and all of it comes together just from general discussions of having a great team and really putting the brains together and finding a solution to the problems. And so this actually started before we announced Funnel. We had our first AI introduction with our Composer software. So we introduced the part recognition and part orientation into our Composer software this past December. And really that was for us to be able to get people using it to give us some feedback on it and to help fine tune the algorithms for the funnel software. Yeah, so anyway, we'll upload all the parts. It will automatically identify them, and then it will group like parts together. And so let's go ahead and I'm just going to accept all these parts. And so what we can do is we can actually go through and check to make sure. And this accepting stage, you can bypass this in the future. But let's say if I'm new to funnel and maybe you need to gain that like trust with the software. We're human, we like to trust stuff, or we want to gain that trust. And so we can go ahead and select all the parts, accept them in. And then from there, the parts will start moving to the parts box. And so it's uploading to the parts box, which will allow us to start queuing the parts over and creating jobs. And so once we have all the parts together, so for example, like we have the splints here, the models here, hollow and solid models, it will then start comprising the print jobs for the end user.
I just have to highlight this, that you guys spent precious development resources on automatically identifying by the object what it is, automatically grouping them together, because obviously if you have a group of night guards or a group of models, you're likely going to want to print them in the same group of resin. So isn't that a smart idea? And I just think this is, obviously it's like in one sense low-hanging fruit, kind of common sense, but it's also just very thoughtful in how you guys innovated this. It's obvious to me you've spent time and money on innovating simplicity, like user friendliness, and people throw that word being user friendly and simplicity around all the time, but what I'm seeing here is the manifestation of that in a really smart way.
Yeah, so it's almost like it's something that the industry has needed for quite some time, and we're able to put it together in a very sleek package. And And so, for example, let's say we imported the parts, we accepted the parts, and now we have our jobs to review. And so these are some jobs I was playing with earlier. I have this job that's ready to review. And so if I click on it, the end user gets a 3D render of the build so they can analyze it quickly and say, okay, yep, this is exactly what I want to print. And then they can, oops, let me close out of that, shrink this down. They can go and accept the job. And then upon accepting the job, it moves it over to a particular device. And that device, then you have the ability to go over and start the printing process.
Wow. And then timeline is scheduling.
Yep, scheduling. This will have a feature soon to be implemented where, let's say, for example, you have all of your printers running, but let's say the funnel software automatically added this job to a machine that maybe you didn't want to run it on. Let's say you want to run it on a different machine. You'll have the ability to drag and drop the jobs onto different machines, which is pretty amazing.
Wow, guys, this is really cool. This is way more than just nesting software. This is like, intelligent file management, file organization, job organization. My guess is this was born out of seeing people have a chaotic workflow and painful, like, I don't know where my file is, or I thought I put it here. And man, you guys really put a lot of investment into this simplicity here. I love this.
Yeah,
Yeah.
I was going to say if you look at individual users, they might be just preparing a few files to print per day, but you get some large laboratories that are producing hundreds of thousands of parts per year, thousands of parts per day, and it gets old pretty quickly if you have to do all that orienting and nesting by hand. So, we wanted it to be a console which is largely automated and an operator can just supervise that everything's running smoothly and have an ability to check and verify it, but to really automate that laborious nesting task and to coordinate a fleet of 3D printers in an optimal way was the goal of the funnel. And the reason we call it the funnel is the idea that it's just a funnel that you throw the parts into without really having to give much thought to its preparation, and it just tumbles down through the funnel out the production hole, and you get the part. So that was the idea behind the name and the concept of the software.
Well, Justin, you are guilty of thinking like a user, thinking like a customer, and wanting to solve a problem from their perspective, which is, I think, that the key to any good R&D, good innovation is, how do I put myself in their shoes, and what would I want as a user? Sure, I just want to drop 50 files on there and I want them to just auto-organize. I mean, I'm sure at some point you had to say that to your R&D team, like, all right, well, we'll write some software to analyze the shape and identify, this is a crown and this is a model and this is that. And I just think it's brilliant. It really is. And very, thoughtful for your users. Is this available today? Is this software that we looked at now available, or is it going to be released soon?
Yeah, well, that's a working copy that you see there. We've opened it up again to some beta users so that we can get some feedback before we open it up. But everything that you saw there was a real demo with software that's running on the cloud. And we're looking to open it up next quarter and taking on more and more users. So it's nearly ready to go.
That's amazing. And, I have a few Rebel agents that might want to stand in line to integrate their design back into the doctor's funnel. And so I'd love to chat more about that, because it's all about simplicity for the end user. The less times they have to click or think or do something, whatever you can do to remove that friction in their workflow is huge. Thank you. Thank you guys for sharing this.
Yeah, thanks for that feedback. Yeah, I always like to try to think, what would Star Trek do if they had to solve any of these problems? If real technological limitations were not an issue, how would they be addressing it? And often that can lead to some creative ideas.
Yeah, and sometimes you have an idea that, initially it's like, well, this might be complicated to solve, but then you dive into it and you have a few smart people on it and they're like, Justin, that's actually not that big of a deal. Probably it'll take a couple days and we can get that done. I mean, my guess is the geometry reading of a crown is probably not too difficult because crowns have a pretty funky shape, right? And, like look at a few hundred or a few thousand crowns and you can train an algorithm to say, there's a crown.
Yeah, it's there are tools for doing that. And then maybe the orienting is in one of the other tricky aspects. As you know, I mean, a dental model is something that's pretty obvious. You want the teeth pointing up, but when you get to some other complex shapes like partial denture frameworks or even just splints or surgical guides, you can get some geometries that as a user you might have experience. You know that there are certain surfaces that are going to be contacting the patient's gingiva or their teeth that you don't want to impact with support structures, and others are okay. So building that knowledge into the process and automating it. I feel that is one of the things that takes the most time. Often just people orienting parts just to print optimally, so they're self-supporting, correct surfaces and not being impacted by the support structures. Yeah, that's probably one of the biggest time savers in the funnel.
Amazing. Well, look forward. So that's an early Q type goal for the funnel to be released?
Correct.
Maybe?
Yeah.
Okay.
Correct.
Well, if you're running at the same pace of PrintPods, then, it's right around the corner.
Almost.
Well, Justin, thank you. Cory, thank you for being here. Wonderful to spend time with you guys. And I think we should do this again when everything's fully released, and Cory, maybe do a deep dive onto all the bells and whistles of the funnel, and even kind of like a mini training session for any new user that wants a good orientation. I think that'd be fun.
Absolutely.
Yeah, thanks for having us, Rob. Great talking to you again.
Yeah, for sure. Thanks for being here. Thanks, guys.
Good seeing you, Rob.